Hello, today I will be showing you a rechargeable battery evaluation that I think will be interesting to some of you. Of course, just about everyone knows nickel metal hydride cells, but I think that few of them have been evaluated after so many years. First of all, let me tell you a bit about these batteries and how they were used. But first of all, about the manufacturer. These Sanyo batteries have been manufactured in Japan. I still expect them to have quite a good performance, although I'm quite certain they will not be up to the level they initially were when new. It's entirely normal. Spending so many years being used even lightly, which I have to say that this is the most likely scenario, is still going to take a toll on the capacity of these batteries and their ability to still maintain a very good charge. However, I'm expecting to see some capacity left because, first of all, as far as I can tell, the ability of Japanese manufacturers has always been very good, and their quality standards in many ways have not been matched by many. So let's see how these batteries stack up. First of all, a mention about the writing that was made originally on the battery, on this actual cell. Well, it's not entirely visible, of course, because so many years have passed and a bit of the initial writing has been scratched away, but I will tell you what was written over here. 1.7 amps. This amount of current was sustained by the battery after being taken out of the charger and spending at least half an hour not being connected to anything. Why this amount of current matters? I have presented a previous video where after so many years of evaluating batteries, I concluded that one of the best ways to rank them is regarding their chemistry. And since we cannot evaluate this directly, we have to rely on some value that we can measure easily. Of course, ideally, we would evaluate capacity by placing the battery and having a constant consumption until the battery is completely drained. However, in practice, I have noticed that most batteries have a specific characteristic to them. And that specific characteristic is that the ability of it to sustain a specific load depends on how much the battery can initially hold. And while we cannot detect that directly, we can use the measurement of the initial current the battery can supply. Of course, we have to be very careful and we shouldn't use such a method with batteries that carry much more current than our measurement device can handle. So in this case, since most of these batteries cannot deliver more than 2 amps or 3 amps, it's not a danger to use a simple digital multimeter that can handle reading currents up to 10 amps. So this is the concept I have been using for many years, and I think it has worked quite well. I was able to differentiate between different manufacturers or different battery, whether we are talking about alkaline or rechargeable battery technology, and even lithium. Just about any battery I tested could have been estimated in its ability to be properly used in a circuit that draws a lot of current. Of course, even if not many circuits actually have those demands, it's important because this is the most likely situation for it. When you have to determine the ability of a battery to reach a specific goal, this is the most important aspect, how much current it can deliver, because most devices can have quite big current requirements. For instance, I don't know, cameras, older portable computers, just about any device that has a motor, so an old cassette player or any sort of device you may be imagining, toys and so on. So actually, this measurement is entirely important. What was written over here was 1.7 amps. This was the amount of current that was delivered. I will be measuring it right now and see how it handles. I have to say that the battery has spent slightly more than that, more than the previously mentioned 30 minutes, because I wanted to determine how the battery handles the charge after some time. And in this case, we are talking about days, probably more than 3 days, as far as I can tell. This is important because as a battery ages, it will be able to sustain a load for much less longer than it usually was able to. This is because the internal construction of the battery degrades in time, and the ability to insulate the two parts that form the actual cell is going to be reduced. And this means that those losses, since they are increasing, it will mean that a bit of a drain happens. And of course there is a curve that can manifest itself in terms of current carrying capacity, or the actual capacity of the battery, because ultimately the two are very well linked, as mentioned before. So when a battery is immediately taken out of the charger, it can sustain a higher load than when it spends some days, because then the small amount of current that is going to be wasted on the battery in storage is going to have a larger contribution to the amount of energy that is still left to be used on the battery. Alright, so without further ado, let's look at the current situation. So first of all, we are having a multimeter over here. It's not a top-of-the-line model, it's actually a quite affordable model that has been quite reliable. And of course, I have to mention again one other aspect. When you're testing batteries, you should be using the same multimeter for all your current carrying tests. When you're not using the same, you can roughly expect, I don't know, something around 10% as most variation between one multimeter and another. Of course, the variation is lower than that most of the time, but in general, it stands at somewhere around 3 to 5%, depending on how the measurement is being taken. And of course, I have to say it again that the measurement has to be taken quickly and with the battery not being put into so many tests, because ultimately then the results will be lower. So we are measuring the peak current that was delivered by the battery, of course. So we are going to the 10 amps range. The connection is already done. It should have been over here for normal measurements, and keep in mind that you should be placing the probe on this connection so that no disasters can happen when you want to accidentally connect the multimeter, I don't know, to a main line or something else that happens. Alright, and let's make the measurement. It doesn't matter if we are using the correct polarity or not, the measurement is still going to be the same. So let's see. Sorry, that was not a reliable contact. 0.94. I think this is the highest value. We can make it again, the reading, 0.94. So this is the maximum amount of current that can be carried through this battery. I'm making sure that I'm making the connection on a wider surface or not using any particular spot in case the connection is not perfect. Now I think that is reliable. 0.97. So we can reliably say that it's almost an amp. So this is what we are going to read. Let's also measure the other one. 0.82. So it's slightly lower. All right. These differences can happen even if the batteries have been used for quite some time. So yes, probably 0.84. Yes, we can reliably say that this one can carry probably around 0.8 amps. So we are going to write on the battery on a side that is not covered by anything else. So probably I will be write it over here. It may not be entirely useful to know what we are doing over here, but I will still say one aspect. When you are having the initial capacity and the capacity that was able to be offered by the battery some years later, you have a very good evaluation of its potential and the potential of a particular technology. So probably if you were to make an evaluation after 1 year and you bought a batch of rechargeable batteries or of batteries in general, you would have quite a good indication of how well the battery happens to behave. However, keep in mind that no two consumers are the same. So except on very well-known loads, you should not make this measurement otherwise than to have an indication of the present capacity. For rechargeable batteries, it's very easy to make the same charge for the same amount of hours and then let the battery spend some time in a controlled environment and then make the measurement. Okay, so 0.8 amps. And over here, I think it was 0.97, so I can reliably say probably 0.9 amps if I were to make a guess, or I could probably say 1 amp. Let's say 1 amp. Because 0.7 is roughly the same. I have not written very clearly over here. Unfortunately, it will take some effort to clear the writing, but I think it's going to be readily obvious what we are facing over here. So 1 amp. And I will show you when the battery was being manufactured. So let's see if I can focus on here. Okay, I think you can roughly see over here that it's the 4th of January probably. No, that's an M, and I don't know. Let's see if this might be an indication, although I'm not entirely sure. It's 07, could be the 4th of January 2007. Actually, I'm expecting these batteries to be much older than that, than 2010. So 2007 or probably 2005 is a reliable indication of the battery's age. I will be taking probably 2007 because that seems to be a safe spot. So 15 years for these batteries. How do they handle after so many years? I think that they handle very well, because we have to keep in mind that those batteries have been used, or at least they spent 15 years, and they are still able to take a charge and keep it quite well, considering their age again. Because as you noticed over here, both of them had roughly the same capacity initially, and right now one of them is slightly more degraded than the other, but still holding half the charge or half the estimated capacity after 15 years. I think it's a very good performance. So I cannot think about anything to be said wrongly about these batteries. So again, a very good performance, and I think that those batteries still will be able to be successfully used. What you should be keeping in mind if you are using older batteries, as is the case here, I think that it's better to find them places where they are not so stressed up. In general, the lowest stress you can probably think for a rechargeable battery or for a battery in general is in remote controls, because remote controls are being used quite rarely in some situations, or even if they are used slightly frequently, they are not going to require high currents. So if the battery is not able to supply higher currents, which is probably the case most of the time, it will still be able to work properly with these batteries. What again is very nice, as you can see, no leaks, and I should have started by saying that because it's highly important. Although rechargeable batteries in general have quite a good construction, expecting such a good performance after 15 years is nothing to brag about, or nothing to sneeze at. To be more correct, because nothing to brag about is, of course, what we should be striving for. I mean, having reliable technology. Another very important aspect is that those batteries have been used probably for at least 100 cycles. I'm thinking about slightly more than that, but I'm not entirely sure because I have not kept track of this. But probably we are talking about more than 100 cycles. So in this case, you have to think about how they worn off in time, mostly due to spending time in storage, being slightly charged, not used for quite lengthy amount of time, but still time takes its toll. So I think this is the context that best describes the battery and their situation. So I hope you enjoyed the video. It was perhaps slightly longer than you would expect for a test that only took 1 minute, but I wanted to explain more about the idea I had and to offer you insight on how you can consider this way of testing batteries and why it's this useful. So thank you very much for watching. If you like my videos, please subscribe to the channel. It's going to be a massive help. And watch for more videos soon. So thank you very much and have a great day.